Hello everyone, welcome to this video. In this video, we will see how to manage conversation history with chat memory in Spring AI. For those who have not seen the previous video, I would suggest to check out the previous video having the title Use Spring AI with locally running LLM. Link in the description. Now let's see what is chat memory. Interaction with AI model is stateless. It doesn't remember the conversation that we had. Chat memory is a feature in conversational AI systems that helps maintain context throughout an interaction. It's crucial for understanding the user's intent, keeping track of the conversation flow, and ensuring the AI responds appropriately based on past exchanges. In Spring AI, chat memory is implemented to enhance the quality of interactions by retaining information that the user provides, allowing for more personalized and context-aware responses. To implement chat memory in Spring AI, developers need to configure memory settings within the AI's framework. Spring AI provides us with an easy way to do this with the help of advisors. In Spring AOP, advisors are used to apply cross-cutting concerns. When a method matching the point cut expression is invoked, the associated advice is executed according to its type, before, after, etc. This allows developers to separate the implementation of business logic from cross-cutting concerns, improving code modularity and maintainability. Let's get our hands dirty now. We are using Ollama to run LLM in our local machine. Those who already know about setting up Ollama can skip this section. Download Ollama from this website ollama.com. Then you have to install the application and then run the executable Ollama. That's it. Next, you will have to download the model from the models page as per your requirement. In this example, I am using Llama 3. Feel free to try out any model of your choice. Just ensure that the size of the model should fit in your memory. I am using Llama 3 with 8 billion parameters with size 4.7 GB. Now let's see how to download Ollama. Open the terminal and run Ollama pull Llama 3 8b. It will download the model and we are done. For you, if you're doing it the first time, it will take some time. When you're connecting to local LLM via Spring, just ensure that Ollama is running in background. We will be creating a new controller. We are starting from where we are left before. In today's lecture, we'll be creating conversation controller. Let's create this as a REST controller. Okay, this is done. Now we have to enhance our query request to add conversation ID. Next, let's create the getters and setters. And let's create a chat response also. Chat response will contain the response returned by the locally running large language model as well as the conversation ID. In case it is the new conversation, request will not contain the conversation ID. Response will return the newly generated conversation ID. Let's create the getters and setters here also. Let's create the chat client as we did this before. Now inside the constructor, we will create the chat client with the help of builder. Now in this particular case, the way to create chat client will be slightly different. We will create an in-memory chat memory. So to store the conversations, we are storing it in memory. Now this .chat client is builder. There is some typo. Let me fix the typo first. Okay, now it is fixed. Now we have to provide default advisors. Default advisors will be used by Spring whenever we place any request. So we are adding prompt chat advisor, and we are using memory chat advisor. Prompt chat advisor will be using the system prompts. If you are setting system prompts, then for every request that same prompt will be set. And chat memory advisor will ensure that every message sent will contain the conversation history. Chat memory is the interface. As of now, Spring only has a single implementation, which is in-memory chat memory. This is the same implementation that we are going to be using. So we have set two default advisors, one for setting the prompt for every request, and one for handling the chat memory. Now let's get to setting the endpoint for us. We'll create a post mapping for chat memory. And now we will be returning chat response. Here also we will be using the request body, and request will be of type query request. So first we will check if the request contains the conversation ID or not. If it doesn't contain the conversation ID, it means it's a new conversation, and we have to generate the conversation ID. So we are checking for null, and we should also check for empty. So we have checked for both the conditions, and if it meets, then we have to set the conversation ID. So let's create the conversation ID. We are using UUID to string. Okay, this is done. Now let's see how to use this conversation ID. It's pretty simple actually. So let's try to invoke chat client. Chat client.prompt.user. We have to do request.getQuery. Now we have to set the advisors for this particular request. We'll be sending two params. It should be a.param, and it's a pretty long constant, so let me write this. Chat memory conversation ID. Let me import this particular key. So as a param, I have to set this constant, and value will be conversation ID. Let me set the second param. We have set the conversation ID, and we have to specify how many messages that we want to retrieve. So the Spring AOP should maintain the history of how many messages. And after this, the code is pretty simple. .call.content will give us the string. Let's store this string somewhere. And let's create a chat response. Chat response is the object that we will be returning to the user. Chat response also should contain the conversation ID. And first let's set the chat response. So extract this response that we got from the locally running model into content and set chat response. And now we have to set conversation ID. Now our chat response is ready. Now let's return this. Pretty simple. Let me show you what are my application properties are. First is the base URL where my Ollama is running, and then the chat options.model, the name of my model. Let's run this application now. Let's create a post request to invoke this endpoint. I'm invoking chat memory, and in the body I'm passing my name is Ajit and tell me something about top level domains. It gave me the response. So now it knows that my name is Ajit. So far so good. Also you can see this response contains the conversation ID also. This conversation ID we will use in sending the second request. Now this is the second request that we generated. It is still ongoing. We send the query and we send the same conversation ID which we copied from the first request. In this request, I did not tell it what my name was, but still it knew that my name is Ajit, and it gave me some examples of the domain names which I can have. All of them are having my name. How did it get to know what my name was? It is from the previous request. Since we are maintaining the conversation history, it knows that my name is Ajit. If you found this video useful, please like, share and subscribe.